So the solution set is just -4. Yeah. We are given some information. Let's look at that. We are given the model. The model will be given to you. 1 plus r over n raised to nt. We are told that the amount invested is 11,000. We are told that compounding n times per year. We are told that n is 2. We are told that the annual interest rate, be very careful, 0.0625. And the accumulated amount is 21,000. How long it takes for this to happen? Okay, so we're going to put in the information as 21,000 equals 11,000 times 1 plus 0.0625 divided by 2 raised to n 2 times t. Be very careful with this because we don't want to, although this is divided by 2, so it's going to be a terminating decimal. So this, in this case, is not a big deal. But if we divide by 3 or by 7 or by 11 or whatever else, it may be a non-terminating decimal, and if we don't keep it as exact in this form, we introduce a lot of error. So be careful with that. So here's what I would do first. Divide both sides by 1,000, and of course divide by 11. So 21 over 11 equals this thing. Don't touch that, please. Don't do anything to it. We're solving for t. So what do we need to do? That's the next step.
Get rid of everything. The parentheses.
Say it again.
Get rid of everything in the parentheses.
I will apply natural log. And I will not touch the parenthesis because I may put in more error. So natural log of 21 over 11 equals 2t natural log of what you have in parentheses. Don't do anything to it. And now t is this at the top, this in the denominator. I know it looks ugly, but with enough parentheses, and this time I have no choice. I have the numerator may be okay without parentheses, but not the denominator. So in addition to parentheses inside log, you can, because it's only one term and there was no operation with it, at the top you can omit the first pair, but the outside pair, but not the here. Careful. So we can omit the top. We still have natural log of 21 over 11. And divide by absolutely parentheses to natural log. Careful now. 1 plus 0.0625 divided by 2. Close the parenthesis and close the parenthesis for the denominator. And now you press enter. So it takes roughly to make $11,000 to grow to $21,000 with an interest rate of 6.25% per year. It takes roughly 11 years, or if you want 10.5 years, 10 and a half years. Any questions? Questions, please? Is this okay? Is this okay? Moving on? Okay. We are given a model, which is a equals 543.3 E2 0.02, I think it's 0.02 T, is it? Yes. Okay, describes the population of a county in millions, T years after 2003.
We did this one.
Say it again.
We did this one. Like, can we do this one again?
Yeah. Can you do it again? Felix, you want to start?
I'm so sorry, here before I realized after I printed them out, so this last one, it was supposed to be here, so you can put your work anywhere you want.
Okay, so what am I doing? So that was the model, and okay, so this is in millions. T is 0 for 2003, and use the model to determine when the population of the county will be 733 million. So what do we do? Right. So 733 equals 543.3 E to 0.02 T. Yes, we want to clean it up, so we will divide by 543. Do not really divide, just write it like this. And now natural log. So natural log 733, 543.3, 0.02 T. So therefore T equals careful with the graphing calculator. The correct amount of parentheses, etc., etc. So we have the top natural log 733 divided by 543.3. Close the parenthesis and we divide by 0.02. So roughly 15. 15 what? Yes. So also that's 2018. So now you know that if it happens that you get the negative number for this, you know you should say oops. Okay. Next problem. Okay, which one will we want to continue with? We want to continue with 7. Very good. 7 it is. So we have g of x equals log of x plus 3 minus 1. Here we're asked to graph, show the asymptotes, etc., etc., etc. So we already practiced with those equations. I would immediately write that x plus 3 has to be greater than 0. And that means that x is greater than negative 3, so the domain must be negative 3 to infinity. And now I can present the rest and the asymptote. And of course, the asymptote must be negative 3. There is no question. If the domain starts there, that must be the vertical asymptote. So obviously, the base function is log x. Then I have number 1, which is log x plus 3. And number 2, which is log x plus 3 minus 1. So there are only 2 transformations on this function. The first one would do what to the base function? Left. Left. That's why I started domain from the beginning, so I don't make an error, right? So this is left 3, and this is down 1. Excellent. So we graph because it's base greater than 1, yes. We would graph a function increasing on all its domain or decreasing on all its domain. Yes, always increasing if the base is greater than 1. So here it is. So this is log base 2 of x. How did I come up with 2? Nobody knows. I just like 2.
What do you mean?
So now you told me to shift it left 3, but I have to shift the vertical asymptote first. It was initially at 0, so it moves to the left 3. So now this point that was initially at 1 has to move at negative 3. I'm sorry, negative 2, of course, yes. Because the vertical asymptote is at negative 3. So this is common log of x plus 3. And now in order to move this down, no problem, I'll take this point and move it down 1. So it's right here. I don't know where the x and y intercepts will be. I have no idea. So this is the final graph. And this is f of x equals log x plus 3 minus 1. Is this okay? Yes? So what else is asking us to determine? Let's see. The asymptote, yes. Domain, yes. Range, yes. What is the range of this function? Excellent. That's it. The percentage of adult height attained by girls who are X years old. So X, age, can be modeled by f of x, which is 62 plus 35 log x minus 4. Where x represents the girl's age, yes, from 5 to 15. So x is between 5 and 15. The model is presented only for ages between 5 and 15. Fine. Use this function to determine approximately what percentage of her adult height girls are at 14, the age of 14. So f of x is the percentage of adult height, percentage. We want to know what percentage they are when they are 14, percentage of their height as adults. Plug in 14. Very good. So all I have to do is plug in 14. How much is 14 minus 4? How much is log of 10? It's log 10. Log of the base.
100.
No, it's just 1.
What?
Right? Log of 10, base raised to what power is 10? 1. So how much is 1 plus 35? 1 times 35 is 35, sorry. And 35 plus 62 is 97. So at the age of 14, we reached almost, or I should say, according to the model, we reached 97% of our adult height, according to this model. See how many applications of the log function and exponential functions?
Oh, yeah.
Good. Yes, I think it's quite neat.
I mean, I guess it just depends on if I do research or, you know.
Okay, so we want to expand or condense next? Expand? Okay, so let's look at expanding. and this is log base 4 of the square root, no, it's the 7th root, a to the 6th, b minus 1 to the 3rd over 16. Ready? Where do we start? With the 7th root, which is 1/7 in front. Very good, awesome. And then leave it alone. It can wait outside patiently. Now what?
Subtract base the top.
So I have 3 quantities or 3 factors, right? 2 at the top and 1 the denominator. Yes. So I have log base 4 of a to the 6th, but plus log base 4 of b minus 1 to the 3rd, but minus log base 4 of 16. Remember, the quantities that are in the denominator will always have a minus in front. Can anyone tell us 4 raised to which power is 16?
2.
So this is 2. So then I bring down 6 and distribute 1/7. 6 over 7 log base 4 of a. I bring down 3 and distribute 1 over 7. 3 over 7 log b minus 1. And now I have a negative 2 and I have to distribute 1/7. And this is fully expanded. We used all properties. There's nothing else we can do. You can never simplify log of a difference. This has no property. You don't have a simplification.
So each log of 1/7 in front of it.
Yes, yes. Because the 1/7 comes from on top of everything. Yes. Next one. We're asked to condense. So we have 3 log 2x plus 1 minus 4 log x. We can condense as long as we have numbers in front. Very good, awesome. Log 2x plus 1 to the 3rd minus log x to the 4th. Now what? Yes. So this is log. Do not write log over log, please. So this is 2x plus 1 to the 3rd over x to the 4th. If you want, you can put it like this to make sure you don't make an error. Okay, this page is done. Questions? Okay, let's take a look at number 6. The accompanying bar graph shows the percentage of people 25 years of age and older who were college graduates in certain state for 7 selected years. So we have between 1950 and 2006, 7 different years. So the functions below model the percentage of college grads among people ages 25 and older, f of x or g of x years after 1950. Okay, so 1950 is 1, 1960 is 10, 20, 30, and so on and so forth. Which function is a better model for the percentage who are in college grads in 1980? 1980 means x equals 30. Good. So we are given the data, and we're asked, okay, 2 different groups of mathematicians came up with these 2 models. Tell us for 1980 which one we should use. We haven't checked for others, but specifically for 1980, we're asked to check. So for 1980, I see the answer should be close to 17%. So what are we doing then? I see you're already doing it. You're way ahead of me. What are you doing?
30, right?
Right. So 6.19 and 1.029 to the x power and 337.3 divided by, if you forgot parentheses, you did not get the correct answer. Please don't forget parentheses. And e raised to negative 0.052x, close the power and close the parenthesis for the denominator. And I go to second and table and I plug in 30. And I get both the answers cross. So for the first function gives me roughly 14.6, and the second function gives me roughly 16.3. Which one is closer to 17%? I know it's silly. Yes. So we prefer the logistic growth model for this situation, not the exponential. The logistic growth model. I know it's early to say that in a way. I don't consider it